Hey everyone. So today we're going to be looking at the programming language Go, and in particular the standard library. The net package in the standard library is a pretty interesting one. Go tends to be one of those languages where the standard library is pretty much all encompassing. I thought it'd be interesting to see what we could do with it, in particular the net package. And so I've kind of strung up together, well, I haven't done really anything yet, this idea of having a binary, a Go binary that you pass in a URL and it returns a lot of information about that request. Not so much on a layer 7 level, more so on a layer 3 and layer 4 level. So maybe, the networking and transport layer. So things like the IP address of the server that, that URL embodies, as well as the DNS requests that have had to happen in order for that request to be fulfilled. So the requirements are pretty fuzzy right now, and that's why I have this README open so we can kind of lay them out, and then we'll begin coding. So I'm going to have this more, I guess, in a format of like a live stream. I think that way we can kind of go through a lot of the problems and solutions together. So if this is useful or helpful, yeah, all the better, so let's get to it. So I think with this idea, I'm interested in having, I like to kind of scope out the API itself first. So yes, I'm calling it kind of gURL to kind of, replicate what curl was. Our request will kind of look something like this, right? It would have gURL and maybe an endpoint, right? So passing an endpoint, let's say HTTPS, google.com. And from this request, we'd expect some form of response. Let me kind of make this a bit bigger. We'd expect some form of response from this request, like, let's see the, so let's say like the IP address of the server itself. So let's say whatever IP address it is, let's say 35 dot blah, 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 blah. So this will be this IP address of google.com. We'd also want to know the DNS resolution, so the resolver involved, which would probably just be a set of IP addresses. We can probably also want to find out the DNS name servers, as well as any other transport layer or network layer information that would be useful in this particular case. So we're going to be using Go to kind of code this up. Just give me a second. I'll put that in there. Nice. So we'd kind of get a response like that. Just format this a little bit better. These are pretty much the things I can think of right now, but I'm sure there are more things that will come to mind. So the name servers will probably be also an array. So like dns.google.com, I think is one of them, or whatever the format comes back. So it would have like simple gURL and would take in an endpoint, at which point it would return information about that particular request on that URL. So I'm using Golang here, if you haven't noticed, and Golan's a pretty good Go ID. If you code Go often, I think it's one of those IDs that's worth investing in. But if not, Visual Studio Code works just as well. I just like the code formatting as well as some of the IntelliSense that comes with Golang. So, but yeah, you can easily follow along here. So here's our project. I'm going to keep this README on the side. So let me just open that. Keep this on the side just to kind of keep us honest with our progress. Let's create a main.go file. Like that. I'm going to open this on the side. Much better. Let's close that. We don't need it. Just so we can test this out, I'm going to make this package main. Let's have a function main as well. All right. So the first thing we need to do is kind of have a way to parse in the flags. So we don't really have any flags here. So there'll be some trailing arguments that we can kind of look at to retrieve the endpoint itself. So let's do the flags.args. That returns a string array of the trailing elements on any, I guess, command. So let's see what that returns. Here's where our endpoint would actually be. Endpoints would be that. And our endpoint itself would probably be something like, endpoint and the first element, at least for now. Once we start to build this up, we'll probably have more trailing stuff later, but this is good for now. All right, so now that we have our endpoint, I think the first thing we should do is just make sure that it kind of conforms to what a URL would be. So the URL is the URL package that comes with the in the standard library. And there's a parse function that we can use. So let's just parse our endpoint, make sure it's valid. I know this returns a URL and an error, so let's do var parse error. And for now, if there's an error, we can just panic and just output the error. Will help us with the debugging, but obviously in a more robust sense, we don't necessarily need to panic. We're going to inform the user what it is. But obviously at this point, we can't continue if the URL is malformed. All right, so the couple things we want to extract. We first want to do a request, right? That's how we'll know the IP address of the server we want to hit. There are a couple ways to do this. I think one quick way that we can just hash this out is actually by using, we can use a net dial function. So this is part of the net package. And the dial function allows us to dial on a particular network with a particular address. So I think it's network and then address. So our network in our case would just be a TCP network. In most cases, obviously, as we start to extend this program, we can actually have UDP as well, or what else is there? IP network. So for now, TCP is good. And I think TCP embodies both version 4 and IPv4 and IPv6, so that should be fine. And our address is whatever we got from parsing our endpoint. So let's call this, give it a better name, parsed endpoint. That is of type URL. Let's see, is host good enough? Host should return, I think, just the host name. So that would just be the google.com. I think that's what works best. Well, yeah, we'll get rid of the scheme. The scheme is not too important, especially when you're using net.dial, which I do believe focuses more on the layer 4. And so yeah, this is the documentation for it. Yeah, so it looks like we'll have to put the scheme right after the actual host name. So that's hosts. We can use a format that's printf here. And we can say that's going to be the host and that's going to be a scheme. So that's parsed endpoint host, as well as a scheme. Let's kind of close that. I'm going to minimize this a little bit so we have a bit more space there. Sweet. Awesome. So dial itself returns a connection as well as an error. So let's see what we can extract from that. So we have a connection and an error. It's always good practice whenever you're trying to connect to a network, perform a network request, or read from a file, or do any form of reading from something to close the channel later on. So we'll defer the con.close. So this defer statement will make sure this happens at the end of the main function once that is done. We can check for the error, make sure that there's no error itself. And once again, at least for now, for debugging purposes, we can panic and just output the error, whatever it may be. So with our connection, there are a couple of things we can actually look for. If you've ever kind of looked inside a connection, we can get things like the local address, so our address, as well as remote address. So I think local address could be something interesting that we could actually look at, especially if you want our tool to be used in a debugging sense. We may actually want to know what our IP address is. But the thing about our IP address, it may not be the IP address it may not be the external IP address for our computer. It might just be our internal one, which I think it's good information to kind of keep and see, at least for debugging purposes. So we'll have the local address here. So let's say local address. And as well as our remote address. This will be the remote address for the endpoint that ends up coming in. So we'll actually figure out where this google.com or whatever endpoint you decide to put in, where that address actually is. We'll actually need to wait to output this to the standard out. So we'll do that in a second, but let's just kind of get our variables sorted. All right, let's see what else we can get. I'll be interested in also knowing DNS information. So the net package also allows us to do lookups. And so depending on the input that we've kind of given in, if we've given in like a typical CNAME kind of URL where it's a canonical name, the canonical name is a typically name that we as human beings can understand. It's like the google.com. It's not the IP address itself. If we input, so let's say, let me give a proper example. So the net.lookup allows us to lookup through using the IP address. So to look up the IP using a host name, or to look up a CNAME using an IP address. So, or CNAME string. Is that right? Let's see this. Look up IP. Let's see what it says. Look up IP looks up host using a local resolver. It returns a slice. So it uses a local resolver. Let's see what we can pass in. So let's pass in our parsed endpoint. That looks good enough, I believe. We don't need the scheme in this case. DNS doesn't really care whether it's HTTP or HTTPS. It's really just the endpoint, the actual host name that matters. This will return some form of IP address and an error. So let's just once again panic if there's an issue. Give us some clarity. And what else? We can also look up the name servers themselves. So first, look up the name servers. We can still pass in this host variable. And I think this is going to return a set of name servers. Yeah, an array to pointers of name servers, as well as an error, just in case that lookup does not work. I like using the longer names. They're just a bit more informative. And let's pass in that. So I think just as a sanity check, it would make sense to actually run this right now. So let's print these out. Let's do a format.printf. And let's kind of adhere to this. So let's have a string that says gURL response. We can change this later. Let's do a new line. I actually want to have these stand out a little bit. So let's use a tab. Say IP. Say let's do our local address. There's going to be some string or whatever it is. What am I trying to do? I'm trying to copy that. Local address, remote address. So obviously we've kind of deviated a little bit from the spec, but we're still getting some useful information. We can kind of wean it out later on. Our remote address. We got our lookup IP. So this would be actually interesting to check what we get from our lookup IP and our remote address. Are they the same thing or not? Or are they not the same thing? And let's say our lookup name servers. All right, let's pass in our variables right now. So we need our local address, our remote address, our IP, which could be an array of IP addresses, as well as lookup name servers. Okay, lookup name servers returns a pointer, so that will not actually help. We want to actually see what those are. So let's do this. Why don't we iterate through our lookup name servers and obtain the actual names themselves and not the pointers, because that will just show us memory locations instead of actual strings of our name servers. So let's do that. So it's going to be our name server. So for each name server, let's just add it to let's create an array of name servers. So it's going to be, I think, an NS. net.ns, is that it? Yeah, that's it as well. And I think it's going to be len lookup ns. So creating a list of name servers. The issue with this one is that it returns pointers and not actual values, so it won't help when you only see memory addresses. And we can actually just name servers that I, might be useful to have I there, is going to be equal to is a pointer to name server. Let's see what's inside. It's a string. Great. So we don't actually need this. We can just turn this into a string. Nice. So we have a list of name servers that we can add over there. Awesome. Let's see what we have so far. So we're going to parse in our endpoint from our application. So it's going to be this endpoint here. The next line will parse in that endpoint and make sure that it conforms to our URL. If it doesn't, it's going to panic, throw an error. If it does, we're going to dial that endpoint using this format sprintf that conforms to this. I think it's here. It's golang.org. You can see it has a host name and then the scheme right after. So we'll use that. We'll create that connection. We'll defer the connection. Right now, we're just using connection to get some basic information, a local address, remote address. Then we're going to look up the IP address of this endpoint. Let's see what it is, and then we're going to check up the name servers used to serve our request, and then just add them to this particular statement. Yeah, so let's see what we end up getting. Let's run this. So I'm going to build this project. So let's do a go build. Actually did one earlier today. So basically all this is go build -o gURL, which is the name, just the output. Let me just delete everything and explain it better. So what we're going to do is we're going to go build -o. The -o flag is for the output, wherever you want to call it, gURL. Typically, when you build something with Go, it creates that binary, but that binary is not executable by default. So we want to change the permissions to make it executable. So even as I think an 0775 is good enough. And then we're going to run gURL is the gURL itself. gURL. I'm going to pass in an endpoint. So in our case, this could be HTTPS, google.com. And yeah, let's see what happens. Oh, sorry, I think our change mode is off. We didn't specify that. There we go. So it seems to have failed. Why has it failed? Index out of bounds. Right there. Huh. Oh, yeah, you always have to call flag.parse so I can parse the incoming flags. Makes sense. Let's rebuild. And hey, it seems like we've gotten some information. I wish this was a little bit clearer. Let's add some some carriage returns there. Let's do it at the end as well. Just run it again for a bit of clarity. And bam, there we go. We've actually been able to identify a couple things. This is my local address. This is an internal IP address, and internal IP addresses are typically within a particular subnet. And so pretty much all the devices connected to my Wi-Fi router will be under this 192.168.100.something. But you can't access my IP address using this particular IP. This is just within my network. It could be useful if you want to debug, like what IP address do I have, and maybe do some other stuff with that later on. The next thing we have is our remote address. And so this could be the actual address of a Google server. And you can see we've actually connected on port 443 over here. And what's interesting to see is that the remote address returned by this connection over here, ISCON remote address, is the same address we got when we performed that DNS lookup. So that net lookup IP also returned the same IP address. What's also great is if you're also interested in IPv6, the lookup address also returns an IPv6 address. And then here are the name servers that correspond to this google.com domain. And so we can actually check, I think it's the website we can look at to see. So here's like a web browser. And we can actually test this right here. So let's copy this IP address. 172.217 is definitely an external IP address. You can check I think it's an RFC 1918. Let me open up a web browser. Where's my nearest web browser? There we go. I think it's RFC 1918 ranges. And this will actually let you know what IP address ranges are internal and can only be used within a subnet, and what IP address ranges are external and can be accessed across the internet. But yeah, this is RFC. If you want to figure out what kind of IP addresses are what, very interesting document, by the way. But here it is. Let's check what IP address is that, where exactly it's located. Let's see that. Oh, that's not it. That's not what I want. What's my IP is pretty good. It's a lot of ads. Let's input that there. It's google.com. And this is Kansas. Somewhere in Kansas, corporate. Where's that? Yeah, so my request is actually being forwarded somewhere in Kansas. Let's see what this IPv6 address is. It could be different or it could be the same. I'm not too sure, but this is what we looked up, and these are two addresses we got back. So let me pull that back up. Oh, nice. Somewhere in Kenya. I'm actually in South Africa, by the way. So it looks like our request was served somewhere not too far from where I'm at right now, down there. Awesome. What would be interesting also to do is figure out if we can just, I guess, in an ad hoc way, obtain kind of like the round trip time for that request. There's a very ad hoc way to do that. If you're not aware, you can use the time package to kind of do that. So let's say, where are we dialing? We can have a start time, which is like a time.now. And we can have an elapsed. So when this net.dial is done, when the connection is actually returned, so the round trip has happened, we can do, I think, an elapsed. Should be equal to start time would do time.now. So wherever the complete time subtracted from the start time. And we get this elapsed. Let's say elapsed time. And let's take that elapsed time and add it to one of our elements here. So let's do a Control D. Let's get rid of all of this. And let's have a round trip time. So like an RTT. think that's going to be a string as well. So we're going to use elapsed time.string. I like the string function for time because it kind of figures out the best way. Should it be microseconds, nanoseconds, seconds, whatever? I don't have to deal with that. It does that for me. So it looks like we have a few issues. Yeah, let me get rid of that comma and add a plus. Awesome. Let's run this again. Let's use a different. Oops, what's happening? Let's use a different domain. Let's try like maybe Bloomberg.com. Awesome. So we got the local address. That's my IP address. Nothing's changed. We're using a different port. So what happens underneath the hood is whenever you run a request, the Go runtime, whenever it needs to use network resources from your laptop or whatever device you're on, it will ask the operating system what ports are available for it to use. And typically the operating system is also handling other apps in background. I know I'm using Spotify. I'm using maybe some other Chrome tab that requires some information. So it will shuffle out whatever ports are available. And as you can see here, we're using 2 different ports. This is what will typically happen in most cases. So don't worry if it changes or anything. But notice our remote address is 691. This is a totally different remote address. I'm actually very curious to check that out, where that is. Where are we at? Oh, as you can expect, this is Bloomberg LP. Where are we at? New York. Nice. What about that IPv6? Also, as you can see, Bloomberg actually don't use IPv6. There's literally 2 IP addresses. I think it could be from different load balancers. And what's actually interesting to note is look at all these DNS name server names that Bloomberg actually uses. So there's Ultra DNS, there's NS1, I feel. What else is there? Yeah. So this round trip time took 244.81, whatever it is, milliseconds. Let's do Google again and see if we actually get the same one. So was it 172.217.170.46? No, this is 14. So it's probably a different server that's handling this request. And look at the latency, round trip times. This is 30 milliseconds, 244 milliseconds to Bloomberg. So obviously Google runs the internet, and they pretty much know how to optimize for their connections. But I think this is a good place to stop. There's a lot of stuff that you can actually start to peel off from the net package, and it's I think a testament to the creators of Go, really how well they made the net package. You can literally do so much with it. I was listening to a podcast the other day of engineers at Dropbox who you can go all the way to, I think, layer 2 in some cases, up until the syscall levels with the net package, and really figure out what's happening at a low level. And so we'll be diving into the net package a little bit more and kind of playing around with the different tools that it has and seeing what tools we can create from it. But I think for now, this is pretty much a good place to stop. So yeah, I'm going to put this code up on GitHub, and I'm going to add the link as well. I also wrote a few Medium articles that kind of go into a little bit more depth into actually how connections are made and what syscalls happen underneath the hood in order to allow reading and writing from a network. Where does that happen, And so, yeah, I'll also link those. And yeah, hope you enjoyed this one. I'll talk to you later.